All right, let's dive into a piece of data tech that's been, well, a total game changer, the open table format. If you've been hearing buzzwords like data lakehouse thrown around, stick with me. You're about to understand the engine that makes the whole thing run.
So, to really get why this matters so much, we have to start with a big, kind of weird question. For years, everybody was rushing to build these massive data lakes. The idea was to just pour all of your data into one giant, affordable place. But there was a huge problem. Instead of these beautiful, pristine lakes, companies ended up with murky, unusable, chaotic data swaps. So, what went wrong?
Well, it all goes back to the two classic ways of thinking about data. For a long, long time, you basically had two choices, and they were polar opposites: the super-structured data warehouse and the anything-goes data lake.
And here was the fundamental trade-off. On one side, you've got the data warehouse. Think of it like a perfectly organized, high-end library. It's super reliable, incredibly fast, but also really rigid and, frankly, very expensive. Then you've got the data lake, which was built to fix all that. It's flexible, it's cheap, it can store literally anything. But that amazing flexibility? Yeah, it came with a massive catch. And that catch was chaos. The very freedom that made data lakes seem so amazing turned out to be their fatal flaw. It's what led them to become these messy, unreliable, and untrustworthy data swamps that nobody wanted to touch. So what exactly made these lakes so swampy? Well, for one, they were just not reliable. If a big job failed halfway through writing data, it would just leave everything a corrupted mess. The whole structure was also super brittle. Like if a data source just added one new column, it could break the entire pipeline. And good luck with performance or trying to fix a mistake. It was slow, and there was no undo button for bad data. You know, this quote here really just nails it. Data lakes solved one problem, rigidity. But in doing so, they created this whole new universe of problems around reliability and just basic trust in your own data. So businesses were stuck. They needed the scale of the lake, but they desperately needed the reliability of the warehouse. What were they supposed to do? And this, right here, is where our hero finally enters the story. The open table format. This whole concept was designed specifically to fix the data swamp problem and finally make good on the original promise of the data lake. So what is it, really? Think of it like this. It's a smart organizational layer that sits right on top of all the raw files you already have in your data lake. It doesn't replace the cheap storage, which is great. Instead, it just organizes all that messy data into clean, reliable, high-performance tables, the kind you'd expect to see in a proper database. It's basically the missing brain for the data lake. Now, the best way to really understand the impact here is to look at their key features. I like to think of them as superpowers, because each one directly takes on one of those critical flaws of the old data swamp. Okay, first step, the superpower that just obliterates data corruption: ACID transactions. Now, this is a concept that's been around forever in traditional databases, and it's a guarantee of reliability. It makes sure any data operation is all or nothing. It either works perfectly or it fails completely, leaving your original data untouched. So what does that actually mean? It means you can have a massive job trying to update millions of records, and if that job fails 99% of the way through, your data is perfectly fine. It's safe. There is zero chance of corruption from a failed write. This one feature alone was an absolute game changer. Superpower number 2, schema evolution. Hey, remember how we talked about those old data lakes being so brittle where one little change could break everything? Well, this is the fix. It lets the structure of your tables, the schema, change over time without causing total chaos.
And the real-world benefit here is just massive. It means you can add a new column, you can rename an old one, you can even change a data type, and your data pipelines, they just keep working. The table format handles it gracefully. Your whole system becomes way more robust and way less fragile.
All right, this third superpower, this one might be my favorite. It's called time travel, and it's exactly what it sounds like. Because the table format tracks every single change to your data, it creates this perfect version history. This lets you query your table not just as it is right now, but as it was at any specific point in the past. The implications here are just huge. Somebody accidentally deleted a huge chunk of data? No problem. Just roll back to the version from 5 minutes ago. An auditor is asking why a report had a certain number on it 3 months ago? Easy. You can run a query against the data exactly as it existed on that specific day. It's an incredible safety net. So, when you put all these superpowers together, what do you get? Well, open table formats didn't just clean up the data swamp. They made an entirely new type of data architecture possible, the lakehouse.
And the lakehouse is exactly what it sounds like. It's a single system that finally gives us the best of both worlds. You get the cheap, flexible, scalable storage of a data lake, but with the reliability, performance, and features of a data warehouse.
I mean, just look at the scorecard here. Cost-effective storage, the lake had it, the warehouse didn't. The lakehouse? Yep, you got it. Support for all kinds of data? Check. What about those critical ACID transactions for reliability? The warehouse had it, the lake didn't. But the lakehouse does. Schema enforcement, high performance, you get the idea. You get everything. The need to choose between them is just gone. So really, when you boil it all down, open table formats have pretty much solved that decade-long battle between scale and reliability. For the first time, we can truly have both. And that leaves us with a really exciting final question. Now that our data platforms can handle almost any amount of data with total, rock-solid reliability, what new, bigger, more interesting problems are we going to solve next?